Awesome. Welcome everybody. This is the LeetCode study group. Here we are going to talk about, uh, before everything, can I get a thumbs up for my voice being audible, etc.? Awesome. Cool. Okay. So this is one of those study groups where we discuss all kinds of patterns, most common kinds of patterns for technical interviews and how you may want to begin tackling them. And we'll also go through one medium problem or so, depending on the time, and we'll discover how to unlock these patterns and get more tools into your belt to get more uh, exposure to solving LeetCode problems. Lengthy intro. Let's go to the next slide. I'm Chethana, and I am a lead at Women Who Code Python. I currently work as an associate software engineer at Realtor.com in the US. And my lovely co-host is Karen. She's a lead at Women Who Code Python, and she's a programmer. Yeah. So let's talk about today's agenda in like a snapshot of today's agenda. We're gonna get introduced to this thing called the two-pointer pattern. And we're also going to go through one medium problem, which is called the threesome. It is not the, if for folks who are already familiar with a lot of like LeetCode problems, etc., you would have heard of a similar problem called twosome. But if not, let's like explore it together. So we're going to go over threesome, and we're going to talk about what this problem is, look at some possible test cases, and then try to tackle it based on what the best approach is for time complexity. And we're going to code out the solution together. And we'll also discuss some next problems that we have to tackle. Like there are, because we're starting with a medium problem, we'll have slightly easier ones which you can tackle because of getting introduced to many tools for the medium problem. So we have twosome and twosome 2. I'll talk about them as we go on, and then we'll finish off with a good round of Q&A. All right, so before we say two pointers, sliding windows, and like whatnot, let's talk about patterns. What are they? Why do you need them? And how the heck are we going to use them to solve LeetCode problems or technical problems in interviews? So patterns generally, they're when you look at any kind of LeetCode problem, you will get stuck. You will, for sure, you would start questioning why I'm even here, doing here. Am I even fit to be here? And everything, imposters, everything will creep in. But before that, if you have kind of problem solving techniques within you in your arsenal, then each problem that you see, you can literally see the pattern that you want to use for the problems in time. It initially it's got a little bit of a steep learning curve, but as you go on, you will see you will start to see these patterns when you look at certain problem statements, etc. You will hear a lot of people talk about patterns in the community, in LeetCode, in general, everywhere. So it's important to know them, and at least to know 70 to 80% of them, so that we have the brain power to learn more as we go on. So with that, let's talk about two pointers. What is the two-pointer approach? So this, like I mentioned before, it's a problem all of these patterns are problem solving techniques. So the two-pointer approach is a problem solving technique used on any array, matrix, or a list. Or when I say list, I even mean sometimes linked lists, etc. And when I say arrays, in terms of Python, they're lists. So specifically during the course of this series, if I say arrays, or instead of a list, it means an array. I mean, it means a list. What am I doing? But yeah, so I come from a like a C kind of C language kind of journey. So like Python is one of those amazingly dynamic kind of languages that I sort of picked up and saw the magic of. So yeah. Now let's look at this particular input. Look at it closely. I have like another like a question for you in a second. When we say two pointers, there are 2 pointers literally at the -3th position. I mean at -3 and 60, which is the 0th position, and 0, 1, 2, 3, 4, 5, 6, 7, right? 6 or 7 at the end of the array. So we have 2 pointers, and these would be at the start and end of the input. And we will do some kind of comparisons of the elements at those 2 pointers, so that we can progress the pointers either left or right. So basically that's the pattern in all of its simplicity. It's not as simple when you have multiple kinds of patterns playing into one problem, but this is very, very efficient, and we'll see why. Okay, so I said that I'll talk to you about a question. I'll ask you a question that I thought of. So what, type to me in the chat, or yeah, type in the chat what kind of pattern or what kind of organization you see in the input array. So it's -3, -1, 0, 7, 10, 13, 60. What kind of, yeah, that's pretty cool. Wow. Yeah, that's awesome. They're all sorted in ascending order from smallest to largest. That is the primary prerequisite of a 2-pointer pattern, is that your input array should be sorted, and you need to make some kind of comparisons between the array elements. And why should it be sorted? That's another question, in case you're wondering, because based on some kind of condition, you're going to be moving them either to the left or to the right. So if you don't have any kind of like organization or any kind of structuring around your input, you wouldn't really end up with good results. You're going to end up with completely wrong, opposite kind of results. So you're not going to do any kind of crazy stuff. You're just going to move them based on conditions. You're going to move the pointers based on conditions. So why how does it reduce the number of comparisons, right? Like, because you know how the input is going to be organized, and you don't really have to do like multiple comparisons based on, like, for one iteration, if you just compare something once, you don't have to like look at it again. Like, you don't have to go through it again. And this would vastly help reduce computation time. And most of the time, it brings down time complexities from, maybe if you see O of n square, it would bring it down to O of n. Or if you see an O of n cubed somewhere for a brute force, and when I say brute force approach, I mean something that does not have any kind of optimization. I will talk a little bit more about that for the threesome problem that we're going to see. But yeah, so it would essentially make sure that we're doing this in linear time, and O of n is mostly called linear time. So yeah. Okay. Now, how do we use it? So we saw the when and the why, and we also saw the what. So how do we do this? For that, I've linked the threesome, like the LeetCode problem in here. So like, feel free to like see it, read it. But like, what it essentially is this is the problem statement that I've copied from LeetCode directly to the slide. So given an integer array nums, I'm sort of like fast forwarding, and instead of talking in plain English about how to use it, let's look at it with an example, right? So yeah. So given an integer array nums, return all the triplets, nums of I, nums of j, nums of k. So that's a triplet. And I, j, k are indices within the array, such that I is not equal to j, I is not equal to k, and j is not equal to k. And these are all like, they keep piling on these things, but in an interview, always make sure you understand what kind of input you're working with and what kind of output you need. So we will talk about some kind of stuff here. And what is the target that they should add up to, right? So it's nums of I plus nums of j plus nums of k equals 0. So 0 is the target that we're looking for. Notice that the solution set must not contain duplicate triplets. That makes it difficult, right? So we can't just do like a normal kind of, like we need to, it's not too difficult, but it may not be too difficult. It was difficult to me the first time I saw it, but so we need to make sure that we do not include duplicate triplets within the whole array result set of triplets. Okay, so at this point you may be wondering, okay, we have like this problem statement. Before you like straight up start jumping into code and like just I'm sure you would have read anywhere or like everywhere that you need to make sure that you ask certain clarifying questions first. We shouldn't just assume things. So let's just try to assume it in this particular case, because we are the interviewer and we are the interviewee as well. So let's see. Yeah, like a couple questions, right? Like let's simplify that, whatever we saw before. The input is an integer array. Integers would be positive and negative numbers and so on. And the output is a list of triplets where each triplet sums to 0. Yeah, I shouldn't have said all of that before. We could have gone through this slide, but we learn. So and no duplicates in the triplets result. Now, as we were saying before, what kind of assumptions do we have? Yeah, so let's see. I wanted you folks to drop in the chat what kind of questions would you think of asking in general, like when you have something like this, like a blah kind of statement. What kind of questions can you ask the interviewer, or what kind of assumptions are you going to make? Can you think of maybe like 1 or 2 questions that you may ask? Okay, can the arrays be empty? What are some restrictions you have for me? Good. Okay, unless all values are 0, duplicates cannot sum up to. Yeah. What is the input array? Did you mean that like mean that like they would need to give you an example of it, or could you clarify what you meant by what is the input array? Okay, and if the array is not sorted, can you use built-in sort? Oh, okay, yeah. Oh, so I can see there are like some good questions in here. Yeah, so yeah, let's move with that actually. So some of you were saying, yeah, will there be negative integers? They did say integers. They never said like positive or negative. So we're gonna assume that we're gonna have negative integers. Can we use other data structures to solve this problem? I think that would depend on when you're actually like talking about the approaches. So let's do this. Let's quickly let's actually deal with the data structure part of it when we're coding, or like not coding, when we discuss like the approaches and stuff. We're still not there yet. We're still in that whole ideation phase. So yeah. Yeah, some good things were, do we use built-in sort methods? Can the arrays be empty? Will there be like, if you say integer arrays, do you mean positive and negative together? And so on. And amazing questions. So yeah, let's code. I'm gonna, yeah, oops, sorry, that's quick. So I'm gonna try and drop the, Karen, could you drop that in the chat, please? Awesome, cool. Okay, so I hope everybody can see my screen. And what I've done here is I've just created like a REPL with just this particular session, and then there's a main.py where you're importing the threesome, you know, Python file that I had there, where we're gonna write out our solution. And I've also written a couple of basically I've taken a couple of test cases either in my head or the examples from LeetCode. So, you know, if you think of some more, feel free to add them in these, like just copy out these print statements like this and then just add them below. Okay. For now, let's not do the examples for now. Let's go to our actual, like, let's look at our problem again. Okay, so imagine you're in an interview setting, right? Will you start coding? Obviously not. You're going to talk about examples. And what are these examples? These are the things that you ask your interviewer. If you don't want to immediately say, oh, can the arrays be empty? Or like, if you feel that it's too quick to ask those questions, you can, while typing out the examples, maybe we can think of like different edge cases or something like that, and we could ask. I had them pre-written before because I didn't want to waste some more time on it, but we could definitely add a lot more examples here. Okay, so in this particular case, let's see, -1, 0, 1, 2, -1, and -4. So for this, the output is going to be this. And let's talk about why or how, right? Let's see, we have a -1 here, and then we have 0 and 1. If you look at them, I'm just going to do it haphazardly. I don't have like I'm doing it as a human being would. I'm just looking at the input and trying to see, if we can add that to the results. So I'm not doing it like thinking of any kind of approach or anything. So this would be a triplet, right? So this could add up to 0. It's going to be one of our triplets. But the same triplet should not be added again. So if because you see another -1 over here, if you come across this, it should not account for -1, 0, and 1 together and add it again in your result set. We don't want that. And what else do we have here? Let's see. Okay, so we have, like we have -1, -1, and 2, right? Yeah, so that's pretty much it. That's how I'm going to see it as somebody who's just looking to see if I can get the right output. What if we have something? Okay, now let's go back to those edge questions that we were all talking about. What if the array is empty? So return an empty set then. We don't have the solution, so we're just going to return an empty set, empty list. And if we don't have the target is 0 here. Just gonna write that down. Your target is going to be 0. Okay. So if we don't have 0, if no triplet adds up to 0 within the array, then we're gonna return so we're gonna return the empty, we're gonna return the empty array again. Cool. So I think, and one more thing is, before anything, we're seeing that we have different inputs that are not sorted as well. Like, we need it to be sorted, right? So like those are some of the examples that we have in our head, right? Like, if you want to add more, either add it there where we can test it later to see how we're gonna get the results, etc. Or we can either otherwise just drop it in the chat. Okay. Okay, maybe we could add the examples a little bit later because it would keep changing in the server, I guess. Cool. So let's talk about approaches. What do you think is a good brute force in here? Okay, if it were me, a good brute force would be exactly 3 for loops. You're gonna loop based on, I'm gonna copy this out into our brute force. Awesome, guys. You guys are killing it. Great. So we're gonna have for this particular, for -1, this is going to be our first number or first element in the triplet, in one of the triplets, right? So for -1, we have to find a pair that equals 0. So we're gonna keep, for -1, we're gonna look at 0, 1, 2, etc. But again, there's another weird thing, right? Because we're gonna have to find a pair. So again, we're going to run 2 more for loops for this guy. Like we're going to, we would have like an outer loop where we iterate over all of this individually, each of these elements individually. And then we will have another loop which sort of iterates over the rest of it. And then another loop that begins from here, maybe. So essentially we're left with this, and let's see, this, and then this. So for every iteration here, this one would move all over. Like it would take out all of these, all of the, like the rest of the array, it's gonna loop through all of it. Okay, so this is not, I'm gonna choose my changes for a while. I don't know if you can see it, but okay. Yeah, so now, what do you think the time complexity of this is going to be? Because we have 3 nested for loops. Please drop it in the chat so that we can see what we get. Good, pretty good. Awesome. It's actually O of n cube. Why is it O of n cube? Because for every single loop, for loop, it iterates over the entire array. The array size is n. So the time complexity for that for loop would be O of n. So since we're nesting loops, it's going to be O of n times O of n times O of n. Yeah, I don't know if I said that right, but it's going to be O of n cubed because we're doing nested for loops and we're doing 3 of them. Now, that's not really ideal, I would say. Again, we're not really taking up too much space either for this. We're taking literally no space for this. We're gonna, although we don't do any kind of space kind of computations, we're taking a lot of time. And could we trade off the time for some space, etc., with some kind of algorithm? So that would be where our 2 pointers come into play. Okay, so how would we use 2 pointers to do this? Before everything, when you're starting with 2 pointers, just let's first look at this guy. He's not sorted. Anything else, they're not sorted. So none of them are sorted. So we're gonna first start by the nums that we have. And what time does sorting take for us? Python uses timsort. It's like a hybrid sort between merge sort and another kind of sort. I forget, but it has a time complexity of n log n. I'm not going to go into depth of why it is O of n log n, but we do like it basically, for every kind of computation, your search space would be like halved or something. So like if you want to like dig deeper, I could maybe leave in a link on the slides or something like that, because there is like a mathematical, like proper kind of explanation for it. And yeah, so so that's O of n log n, right? And then how would we take care of the rest of it? Like What do we do next? So that's what we're going to talk about right now. So now we all follow that. We all understand why it needs to be sorted and stuff, right? Any yeses or nos? Drop them in the chat if you all sort of get why we're sorting. We need the input to be sorted. So cool. Thank you. Awesome. Now let's get to the main question. So now what do we do for this particular weird kind of situation to find the triplets? Okay, so let's begin by sort of like we're gonna have like an outer pointer that takes care of it would sort of like start iterating on the outside, but within that, like after that, we're gonna need two more pointers to keep track of what's happening inside, like within that particular like, how do I explain this? Let's see. I feel like I'm not doing justice explaining, but so for -4, which pair sums up, or if you generally, how do we find out, right? For this, we're gonna it's gonna be like nums of, let's call this I, because in general, like anytime anybody's like starting to like, if we're going to go through an iteration, we're just going to use I. Okay, so and after that, let's call our, we need to have 3 pointers, right? Let's call our the one right after the outermost pointer left. You'll see why in a second. And let's call this right. Okay, the one at the end. Yeah. So that should be equal to 0. So 0 is your target. So now that we've already figured out, or now that we already know what the first element is going to be, or like where we're positioning the first pointer, simple, like this kind of thing is just like, we're just gonna sorry about that. Interesting. What did I do? Okay, I'm gonna just write it down over here again. Let's go one more round. Nums of left and nums of right. They should equal to 0, and which means this part of it, it should equal to your 0 minus, okay, it should equal to 0 minus nums of I. Nums of I is the first element, first position, wherever you position the first pointer. Okay, so we have to, so basically for this, we would need to do our usual 2-pointer approach, right? This is not really, this is just going to go, this is an outermost pointer, which is not really the 2-pointer approach. It's just going to keep iterating for every element within the within nums. Okay, now let's try. This is already sorted, so let's try. Our first target, our first thing that we're looking at is 0 minus -4, which is 0 plus 4, which is 4, right? 4 is the first, wherever I is positioned, and I is positioned here. Okay, so we need to find like a pair of numbers that add up to 4 from the rest of the array. Okay, now let's start with the first. -1 and 2, they add up to 1. They don't add up to 4, so we don't, it's not the right one, but they do help us understand where our left or right pointer should move. They govern where our left or right pointer should move. So yeah, so now we have 1, right? So is 1 equal to 0, or like, greater than 0? Obviously it's greater than 0. So yeah, okay, so if you folks have like some kind of code changes or something, feel free to like make them right at the end of the session. Okay, cool. Yeah, so we had target of 4, and our first one, it equaled 1. So we're going to be moving, because it is greater than 0, we're going to be moving our right pointer inward closer to the lesser elements in the array because they're sorted in ascending order. So let's see here. Okay, so we're here now. What is negative? What is -1 and 1? Does it equal 4? No, it doesn't. So let's keep going. Actually, it equals 0, but we need to yeah. So what was I doing? Sorry about that. I think I sort of caught myself doing some weird stuff. I'm going to yeah, so it's 4, and -1 and 2 is going to be 1. 1 is greater than 0, so we're going to move this inwards. And because we're moving it inwards, next we're going to check for -1 and 1. They don't they're I think now we would, for this particular iteration or whatever, we would, I feel like I'm okay. So now next we would look at any kind of iteration or any kind of triplet that is going to equal to your that's going to equal 0. I thought I could like explain like everything step by step within it, but I feel like we're gonna lose out on some more time there. But yeah, let's see how it goes. I'll just explain like the gist of how we're going to try and do it. So for every element here at wherever your ith pointer is, or like your ith index, we're going to find a pair that would match it, like where your entire your nums of I, nums of left, and nums of right are going to equal 0. So one thing that we need to keep in mind is that we can't use duplicates, right? So suppose you're over here, right? We would definitely find a solution over here because it's going to be a -1. Let's suppose we moved our ith pointer to the next one, because the -4 is not going to yield us results. Every time we add those 3 numbers, it's not going to give us 0. So we're moving to this specific one. And when you see immediately over here, this is -1, and this is -1, and then this is 2. So that whole thing that we're mentioning, that's going to equal 0. And so this is a valid triplet, right? So we once you see a valid triplet, what do? You just add it to your result set. So it's going to be -1, -1, and 2, right? Okay, that part is done. Once you add it to the result set, what happens now? You basically just move progress your left pointer 1 place to the left and your right pointer inwards, just like you would do for any kind of like algorithm, like any kind of question where you just have to move to the next iteration, right? You have to look at the fresher set of inputs, or fresher set of like I and J left and right pointers. So you're here now for -1 plus 0 plus 1 is going to be 0. So we have a good triplet. Let's add it. Okay, so -1, okay, 0, and 1. Cool. So there was, I'm quickly looking at the chat also, getting super distracted, but like, yeah. What sorting method are we using again? We're going to use the inbuilt sort method for this one, because like Tim sort is anytime in an interview, if you get like a question like this, the sorting is not going to be mostly the higher priority. it's going to be how you approach the rest of like the actual problem statement. But in case they ask you to implement your own sorting algorithm, you could use something like merge sort or something like that to come up to code that up. Yeah. Okay, so we included our good triplets of this particular case. Now every time for the internal pointers, you would always make sure that your left pointer is lesser than your right pointer, because they don't go like that. If they change, if your right pointer becomes lesser or something like that, then it means your order is all messed up. So it cannot move inwards. That's your stopping position. Cool. So we've processed for -1. So we're going to move to another -1. But hey, okay, let's see here. Let's add. Okay. So let's add our two actual pointers to wherever we want them to be. Right after I, one to the end, and one right after I. Okay. So this would obviously this particular case is gonna be weird because you've already like this one would not error, or this wouldn't give us like the triplet that we want, but let's try here. Okay, so we have again we have -1, we have 1, and then we have 2. The issue that the thing that I was trying to say earlier was I was trying to do like 0 minus nums of I to get the rest of it, but that's not how threesome would work. You would always do like the value at all of your pointers, the 3 pointers, is it equal to 0, greater than 0, or lesser than 0? Those are the 3 cases that you would always, you would think about for this particular case. Yeah, so we're currently over here, and then we see that this is not working out, and this is 1, right? 1 is greater than 0, which means you move your right pointer to you move it inward, closer to the left, because you want to reduce the value or something like that, because it's sort of in ascending order, right? Okay, so now we see a good triplet. Should we add it? We shouldn't, but we just wasted 2 more iterations trying to figure out that we shouldn't. So how about we stop all of that? Once we see an immediate duplicate right next to the outermost pointer, if we already process something like that, don't process something similar to that, right? We would be wasting computation times. Suppose we had like another kind of like duplicate or something, and we had like, I don't know, -2 or -2, some other numbers. We would literally sit and waste so many computation cycles just to get through them, and we don't really want to do that. So skip right at the beginning. Anytime you see a number or like something right next, they would always be right next to each other because they're sorted, so makes it easier for us. If you see anything that's already sorted, or I'm sorry, you see the same kind of numbers, skip it. Okay, skip until you get to a unique number. That's for the outermost. What happens for like the innermost, like the two actual 2 pointers? What do we do for them? We sort of increment for the left pointer. We keep incrementing until we get to a unique number or a unique value. And for the right pointer, we keep decrementing until we get to the next unique value. So that is that is how we're trying to handle duplicates and everything, like just so that it would make it easier, like the outermost and then innermost 2 checks. We're done. Once we do that, we're done. Okay, so now we've sort of like discussed this. What exactly would be like the time complexity for this? It's going to be I shouldn't say it. What do you folks think? 1 second. I'm just gonna check a question in the result just to confirm the first list is where the pointers are at. Ooh. Oh, okay, okay. Yeah. Sorry about that. Yeah. So the first, did you mean within the two pointer, like this particular section, or where did you mean it? Because um, this is the actual input, and this is the result. I'm sorry, I should have written it clearer. But when you're like this would convert, this input would give you this result, is what I was trying to say. Okay, cool. Awesome. Yeah, I guess yeah, I'm wondering, somebody's cleaning up my code. Thank you. Cool. So where was I now? Yeah, so again, like I think I was asking you folks about time complexities. Okay, yeah, cool. O of n square. So why is it O of n square? You're gonna iterate for every number. For I mean, you're gonna have like an outer loop that runs through the entire list, and then you'll have like an internal like uh, loop where you're gonna have like a okay, you're gonna have your left and right pointers, your left and right pointer here, and you're gonna check. Um, you're going to move inward or outward. That movement itself is like, it's like a loop. For that, you're going to check the rest. I mean, for the ith pointer, you're going to check the left and right pointers. So O of n there and O of n here, nested loops, so O of n squared. So that is going to be your time complexity. Sadly, I don't think we can do better than this. And also, if you remember, Tim Sort does O of n log n, does it in O of n log n time, and O of n square would be the actual like the logic for finding the triplets. So if you look at it overall, the upper bound is going to be O of n square, because n log n is that time is lesser than n square. So yeah, so that's going to be the time. The space complexity, I think it should. I'm guessing we're not gonna really take the space complexity of the result, because that's what we're returning anyway. And I'm just wondering, because like Tim sort, it would need to do some kind of internal computation where it moves the array around, right? So maybe that takes up. Let's just give it some kind of upper bound, uh, maybe O of n. If you, in the worst case, you need to move everything around, like you need to shift by O of n or something. Um, it's negligible compared to like we could definitely trade off some amount of space for the time that we had before. It was n cube, now it's n square, significantly lesser. Cool. Now that we have that out of the way, of course there are other approaches. Like if anybody's done twosome, you would have also seen. Okay, you would have also seen. Uh, yeah, so you would have also seen something pertaining to a hash set. Like a dictionary. Use a dictionary, and then once you see some kind of target, you add it into like the dictionary. If it's like it's a bit, yeah, how I think I would have to write it out to explain it, but there is a hash set solution even for this, hash map solution even for this, actually hash set. uh, but that would, again, that would all apply to the second portion. I mean, the outer pointer has to be there, like the ith pointer has to be there, and then for the rest of it you find like a pair that that would eventually add up to 0 with the outer pointer's value. So yeah, I'm gonna choose the two pointer approach now because that's what we're talking about. Let's code it out. Yeah, so do you think is there anything else that we haven't addressed in the approaches? Or also, if you have any more favorite approaches or something, let us know in the chat. And if you all are on board with it, let's start coding it out. What do you think? Looking at the chat. Okay. Awesome. Let's start coding it out then. Okay. Let's first let's knock out our edge cases, right? We have, again, before I start coding, sometimes to avoid a lot of nervousness, etc., it's good to maybe, if you want, you could comment out like pseudocode and then get into the actual coding. But sometimes it's I mean, that actually swallows up a lot of time in interviews, and then I think you would just have like 5 minutes or so. And I would definitely say that sorry, I would definitely say that if you've thoroughly like decided on what approach you're going to take, and like, everything, the coding portion is not going to be that long. It's just going to be like 5 or 6 minutes or something, depending on the problem. But yeah, for this one, it's just going to be like 5 or 6 minutes. So yeah, cool. First things first, edge cases, right? Okay, so if not nums, can type. Okay, if not nums, if you don't even have nums, or if the length of your nums is lesser than 3, what do? We just return like an empty set, because that's what we want, right? We don't really have like a solution there. Okay, now seems like my interesting. Gonna wait there for a second. Technical glitches. Okay, cool. Hopefully we're gonna solve everything better now. Okay, so now let's just create a result set, just because we want a result set, right? And then at the end, let's just return results. This is good practice, because I've seen a lot of people, and believe me, anytime anybody is doing a lot of lead coding, they will see a lot of folks everywhere doing Twitch streams, doing YouTube streams, etc. And all of them always have like this really cool pattern that we can like pick up from. I definitely liked when folks usually write out everything. Like if they declare something, they would return it, just like you're doing with, I don't know, braces, but you have braces auto completion anyway. So cool. So yeah. Now how do we start, right? So let's loop through lead coding for I in range of length of nums. Pretty standard so far. We're gonna iterate one by one, right? Thank you for calling that out. So we did forget one slight thing. Remember, we need to sort. So let's sort. And why is that doing that? Weird. Anyway, let's sort first. Okay, my code is constantly changing. Can you let's see where we can move this to. Definitely not sure why it changed. Sorry about that. It's taking some time, and then my code has changed quite a bit. This is sad. Folks, I would really request you to not change the code because we're almost going to we're almost going to finish it. Trust me, just bear with me for some more time, and then we would have our solution. Cool. I'm gonna say this again. So I'm just gonna do it real quick so that we don't have to all like wait and. Okay, now we're at a decent position or place. And again, let's sort. Thank you, Tracy, I think, yeah. Cool, so now we've sorted it. Let's start going over number by number. Probably REPL's not the right way to go. Cool. For this, we're doing number by number, and now we would need to anchor your left and right pointers somewhere, right? You need to anchor them such that they do their own thing inside, and this outer pointer, I mean outermost pointer, it keeps iterating over everything. Let's go ahead and do that. So your left pointer is just right after the ith pointer +1, and then your right pointer is going to be right at the end, since Python is 0 indexed. Okay, after this, now we're gonna do like our internal, like, you know, while your left is lesser than right, you need to do the actual moving, and you need to do the moving of the pointers and checking and adding to your triplets, that kind of stuff. So while your left is lesser than right, let's do like a target within this. So your target would be, can't even type, okay, nums of I, nums of left plus nums of right. Ooh, that is bad. It's stuck, completely stuck. Cool. Plus nums of right. Okay, so now we have this kind of like, this target should be equal to 0 ideally for us to add it to our result set. So yeah, if target equals 0, what do? We don't do much. We just append it to our result set. What are we going to append? We're going to append our nums of I. It's going to be a triplet set. So 3 elements in, it's going to be, our result is going to be like a list of lists, right? And each internal list is going to be of size 3 because it's a triplet, just reiterating it in general. And we're just going to add, this is a good pair, like this triplet pair is a good pair. So we're going to add it here. And then what do? We just basically increment our left by 1, and then we're going to decrement our right by 1. We're going to move them closer so that we get more triplet sets, etc. And else, if your target is lesser than 0, what do we do now? Then that means we need to increase we need to add more value, or we need to increase some point there. So we need to move our left pointer closer to the right because it's sorted in an ascending order, and you get the gist. So here we're just gonna increment our left pointer by 1, and at the end, usual stuff. So we're gonna decrement our right pointer by 1. Why? Because again, now we found out the target is greater than 0, and we don't really want that. So we need to lessen the target some way. So lessening it would be moving one of the values, making one of the values lesser. So move the right closer to the left. Okay, and I forgot that our code changed. Okay. Let's see. Okay, so hopefully I don't run into indentation issues or anything like that. Maybe I do. Huh. No, I don't. Okay. So now we haven't really dealt with the duplicates part of it. So let's do that. How are we going to deal with the duplicates? Skip. If you see like an external, like the outer loop thing, if there are like elements that are equal to each other lying next to each other, skip. Do the same thing for the internal stuff. We'll see how. So yeah, so here let's add a little tiny check that says if sorry, my sort of like blanked out there. Okay, so if like your I is greater than 0 and yi greater than 0, we'll see in just a second. If nums of I, the current one, equals nums of I minus 1, the previous one, we're going to continue. There, we could also do like this whole check where, like your I should be equal to 0, and then nums of I is not equal to nums of I minus 1, then do all of this stuff internally. That's also pretty good. Yeah. I'm waiting for the things to diverge, no, condense together. Come on, REPL. Okay. So we've taken care of the outermost, like, yeah. So we've taken care of the duplicates for the outermost thing. Let's do it for the internal ones. Okay, for the left and right pointers. So now, like, oh man, this is frustrating. Okay, so while you are within the same bounds, like your left and right, they're in the same bounds. So while left is lesser than right, and your nums of left equals nums of left minus 1, because for the left pointer, you always increment the position by 1. So if this is the case, then you so this wouldn't really be like an if statement, because suppose for one iteration there are your left pointers may be initially pointing to -1 or something, and then the one right next to it is also a -1, and then a -1, and so on and so forth. You have to make sure that the left pointer stops at a point that is not if there are like 10 of the same similar values that are not unique, you want it to skip through all of it to reach the unique value. So we're going to use a while loop for that. And I'm going to really quickly finish coding this because because of the changes, you folks would get super frustrated as well. So I'm trying to like make sure we do that quickly. Okay, there we are. All right, so in this case, if we see that the lefts are all like not they're not unique or something, they're duplicates, you just keep incrementing the left pointer by 1 until you reach a good point where you say, like, we're done. This is a unique value. Now let's do the same thing for the right. And this time we're just going to do it for right, because the right pointer always keeps moving from the end inward. We're just going to make sure the next element is not equal to the current element. Choose my changes. Let's go, guys. Cool. So yeah, let's do this again. So right plus 1. I hope this particular part makes sense. If not, definitely ask in the questions. We will get back to it, I think, at the end. Yeah. So you need to decrement your right by 1. Okay, we've done quite with all of our like REPL changes and stuff like that. We are finally here. I think even now, okay. Yeah, that could actually, it wouldn't be n cube, because we're within the same iteration, but we're skipping through everything else. Yeah, I'm wondering about that too. Good question. I think I'll get back to that. Yeah. Okay, so now that we have this particular like snippet going on, let's try to see if we can get this to work based on what we have here. Let's see. So, okay. a lot of, I'm not sure how this changed. Okay, so basically what I've, okay, cool. I'm gonna rewrite the main.py file so that we can sort of run our tests, and maybe we can see if we can incorporate some more stuff. Sorry about the delay. Maybe we'll move to like a different kind of like a local, maybe we could do it with like a local editor or something the next time, or maybe a Google Colab or something. Meanwhile, let's see. Okay, would you also share the link to the problems? Oh, sorry, I saw this. Oh, okay. Saw this. I thought I saw this pretty late, but let's see. Just gonna add that into the chat. So that's like the threesomes like problem statement. I am not sure why this thing is taking forever to load. I do see like some sort of like overlap here. Okay, technical glitch aside, let's see. Like, I think we've sort of covered pretty much everything that we needed to go through in those in the code. I'm really sorry that this it didn't work out, that we couldn't run it, but I don't want us to lose more time and not get to the Q&A or anything like that. Yeah. So let's move back to the two-pointer slide to see where the next steps would be. Yeah. So again, like after our sort of like expedition with threesome, there are a couple more changes. Like I think like Sneha mentioned in the chat, we could definitely incorporate that, but I'm still wondering if I still feel it's going to be O of n squared, because we're just within the same iteration, we're just gonna speed up the movement of the pointers. Not sure if that makes sense or comes through, but I will maybe like write out like a description or something in the slides in case you're looking again. And what else? Yeah, and also it's super clunky to have all of that code in one. Okay. Yeah, so I will get to the end of this. Like yeah, so we could also like, again, like separation of concerns, etc. We could basically move out that logic, that clunky logic, into like its own function. Like I think LeetCode has that solution for it. We could do all kinds of stuff with it, but I definitely felt that part was something that anybody could begin and try to understand. Yeah. We'll definitely we're learning on the go. Definitely leave more comments like this so that we can improve as and when we go on to the next ones, because they're tougher patterns. These are all like okay-ish. Okay, so we're now to sum, like we mentioned, very, very popular. Given an array of integers, nums, and an integer target, return the indices of two numbers such that they add up to the target. This is like one of those I guess one of those classic kind of problems that everybody talks about. So yeah, you would basically just have two pointers, and then you would check. You could again you could do like the brute force and explain it to the interviewer, and then explain why two pointers or like a hash set would be better. But this is something definitely you could start with this and then move to the more difficult problems, and then two sum the one that we've mentioned here on the top. I don't think that's sorted. So they have different variations of it. Two sum two is one of those variations. The input is sorted here, so you basically just have to do it would just be like a linear time kind of expression, and after that, I guess just try out all kinds of like two sum and all of that stuff. um yeah, I guess that would be the next steps from here. Okay. Whew, we did like a lot of stuff. um there all honesty, there are like multiple ways of doing this problem. There are multiple approaches to solve it, and so if you have any kinds of like questions or anything like that, just maybe like drop it in the chat or like the Q&A. And I'm sorry if I sort of like skip through some suggestions, etc. I guess like there are, you folks have mentioned a lot of amazing ways to like optimize this. So I definitely think like anytime you're free or anything like that, just add to it. Yeah, cool. So did anybody have any more questions or something like that? Okay. Interview at Microsoft for the position of okay, cool. Question number one. Hopefully you've tried out doing like the LeetCode has these lists, right? They have like these lists pertaining to companies or like lists in general that you can try out. So I hope you folks like Namrata. So Namrata, did you maybe look at the top interview questions or something like that? If you mean LeetCode pertaining to like the technical interview portion of it, tips for that would be just go through like every single day, make sure you do the daily LeetCode problem, no matter what. This is for anybody and everybody within the chat, within anybody within the session. The one thing that definitely helps build up the tools that you need to solve problems is doing the daily LeetCode problems. Some of them they won't be, most of them they're too difficult to be asked in interviews. Some of them aren't. Some of them are exactly interview questions. So just making sure you create that habit is going to like definitely like move you across to so many areas. And if you have LeetCode Premium, if you don't have it, I suggest you try and get it. Since you're interviewing for Microsoft, again, they would have their own list for Microsoft, like the frequently asked questions. Try doing that. And then again, like everybody says, network and talk to people and try to understand maybe from others if you're like what kind of things you can ask, talk to the interviewers about, and so on and so forth. Those are like general stuff. But okay, how long should we spend on trying to solve a coding problem before moving on? This is a toughie, because you don't actually get to the code part of it unless you sort of get to the approach part of it. And if you are stuck at the approach part of it, I think the interviewer would, if you fumble, or like if you at multiple places and like something like that, then they're going to help you with hints and stuff for you to move on. And even if with all of the hints, oh wait, did you mean Celia, did you mean this for online assessments, or like did you mean it in a technical interview where they're like, if they only ask you like one or two kind of questions, then I would say make sure that you try, like make sure the interviewer sees that you're trying. Like, if you don't actually like put in the effort, there sometimes I've heard from mentors, etc., they've always said that even if you don't get to the solution, if they see that you're partly there or almost there, or like you're thinking in the right track, they would consider you, and they would ask you to, like, let's maybe talk next or something like that. So yeah, I would say there's no like definite time limit. It just depends on what kind of interview, your interviewer, how many kinds of questions you're going to get, and so on. So sorry, I don't have like a perfect answer, but yeah. Cool. Would this kind of question be asked for a data analyst job? I'm not too sure. I would think maybe not, but that's just my opinion. You definitely have to. I don't know too much about it, so this would definitely be like a new grad, like I don't know, like, well, for senior levels, obviously there's system design questions, but for data analyst stuff, I feel like, I don't know, the top of my head, I did hear folks say maybe you would a data set, and then you would be asked to do things like take home stuff sometimes. But again, I'm not too sure about it. Definitely check with others on it. Yeah. Did you have any other questions? Or yeah, they don't. Mostly like, I think they do see how creatively you do the take homes and stuff. So is it possible to post the easy questions or warm up questions before the okay, cool. It would be helpful to understand the easy. Okay, yeah, everybody has different ways of learning. You're right. Uh, we do have like the LeetCode study group channel, and I think Karen already posted the invite to the Slack group. Definitely join the LeetCode study group channel. Let's sort of like refine this, because this is like the first session and this is the first time I'm presenting. Like there are many like technical glitches and stuff that we need to like, make better in the future sessions. So yeah. Oh, thank you. Awesome. Um, did you folks have anything more? I'm gonna wait like maybe like 20 more seconds, because like the we would have to end it at 8:30. I mean 8:30 Central Time. So cool. Yeah. If you have any more like general questions, I'm sure there are many opportunities and ways for me to like ramp it up more for you folks. So if you need more of like a breakdown on like brute force solutions, and uh, me spending a little bit more time on time complexity and stuff, I did not do the best job explaining it today, but I will ramp it up for future sessions. So if you have any kind of feedback or anything like that, just let us know in the Slack group or like our channel, or DM either Karen or me. And yeah, awesome. Thank you so much. I think if we don't have any more questions, I'm just going to leave you with some links here. It's the REPL link. Of course, now it's super broken, but I swear I'll fix it. And maybe there's a good starting point. And also see if, if you folks want to like mess around and see. Thank you so much, everybody. Yeah, and this is the repo to the LeetCode study group, and then obviously I think many folks would have heard about PRAMP. That's like a mock interview kind of tool that everybody uses. So if you're interested, we could talk about it in the next session or so. But definitely check that out as well. And also definitely do like the weekly and the bi-weekly contests in LeetCode. Even if you don't get even one solved, you're still there, like, and you're making progress. So just that it would definitely help to break any kind of like anxiety or like nervousness around interviews. So yeah, look at our these would be like our upcoming events for this series, where we have like we would next talk about sliding window, the sliding window pattern, very common with substrings, and hash set, hash map, and so on and so forth. I will try my best to like put in as much material as possible within each session so that we don't, we don't feel overloaded, and also we don't feel like we didn't do much. So cool. And these are upcoming events for our track. We have the CFP speaker series. Just in case anybody wants to give a talk, I'm registered, so you should register. All of us should register. And we have our Python libraries 101 session going on, the series going on, and yeah, and then the next LeetCode series study group on October 7th. And if you want to like register for more events or something like that, just click on that link. The slides and everything would be, I mean, if you I think they would also be in the channel and stuff, so we'll make sure we do that. Definitely join the channel. Cool. And with that, thank you so much everybody for joining and like providing so many valuable insights. I learned a lot from this session, and I hope you have too. And definitely looking forward to doing more sessions and meeting and talking to all of you.